Right, so application-driven infrastructure engineering. So one thing I'll warn you about, first of all, is that this talk might leave you a little bit disappointed and a little bit unsatisfied. And the reason for that is that there's a structure to the way these talks work, right? So the first thing I do in a talk is I tell you about some terrible problem. And hopefully this is a problem that you recognize. You say, oh yes, Kief, that's right. I see this is a problem we have. Wouldn't it be great to have a solution to this problem? And so I will do this. I will tell you, about a problem that I think, many of us have. And then the second part of the kind of standard flow of a talk is that you have, here's the solution, the better world, the answer. Like if things were to work like this, wouldn't things be better? And then you say, oh yes, Kief, that would be great. That would be great. Please tell me how. Then the third part of the talk is where I tell you how. And this is where you're going to be a bit unsatisfied, because I don't really have a detailed plan of this is how you go about and make this world a better place. This is really more about thinking about what we need to do kind of together as an industry, as people in our companies in order to achieve that. So I think hopefully this is a way to think about how we do things like build platforms, for example, in ways that will be kind of more satisfying. So hopefully it will still be useful, even if it doesn't quite give the details of answers that we might like. So thinking about, firstly, why do we use the cloud? And when I talk about cloud, I mean also the kinds of things that in some cases we build in our data centers in order to be able to provision infrastructure automatically, private clouds, this kind of thing. But the idea generally for doing this is about time to market, right? It's about flexibility and adaptability and generally solving some of the problems that we tend to have with our infrastructure. So if we look at a kind of a view of an infrastructure, a view of an architecture, I should say, of an organization, you have that kind of classical, you've got applications that are running on top of your infrastructure, and you've got people that are using those things, consuming them on the top of that. So this is a fairly classic view. And what typically happens, so that problem, that big kind of tire fire that I showed at the beginning, is so from the point of view of, say, teams that are building applications and running applications, they tend to often find that the infrastructure is a point of friction or even an obstacle to doing their work. So they'll see things like there may be inconsistency in environments, which means that an application that runs successfully, is deployed successfully and tests successfully, and one environment may not work quite the same in another, may be difficult to deploy and so on. And so this is often a source of friction. It may be difficult to get updates and upgrades and changes to things. So the application team might decide we need a new version of a application server or some part of the middleware or the operating system that we rely on. And it might be a difficult process and a time-consuming process for the people managing the infrastructure to provide that and make that available. And then often there's just simply a capacity issue where we don't have enough infrastructure for the needs. We needed a new environment to test something. We don't have the environment available. We have to kind of reprioritize and so on. So these are kind of classic, probably familiar for most people, situations that we run into. And then on the inverse, when you have the people who are managing infrastructure and building infrastructure, they are often having friction coming from the application world, where maybe deployments are not consistent or they're difficult, right? So we've deployed it into our pre-production environment. It took a lot of work. Then we go to deploy it in production. And again, maybe it doesn't work correctly, very fiddly process. Maybe applications aren't built in the best way to be more operable and supportable. So, maybe there are performance issues. Maybe they haven't been, written with security in mind and these types of things. And then observability. So when something does break and something goes wrong, how easy is it for me as an infrastructure person or an operations person to troubleshoot the application and what's wrong? So this is the classic, this is why we have DevOps, right? Is dividing these two things is difficult. And it is why we tend to have cloud, or what people are hoping to avoid by moving to cloud. So in a lot of the projects and clients that we work with over the past years, a number of years now, involve some degree of usage of cloud and often migrating to cloud. Let's move our applications into the cloud. And often the expectations is that moving to the cloud will magically remove all of these problems that we've experienced before. And reality is quite often that actually you bring those same problems into the cloud, and you have these same difficulties. And worse, you may have more problems now because cloud adds complexity. There's new moving parts, new things that you need to worry about, and new ways to kind of manage infrastructure in the cloud. You have new concerns around security. There are different threats that now become relevant in a cloud environment that might not have been a threat so much before. And things may just be more fragile. So this is usually just a matter of just moving directly the things that we have in the way that we had them in the data center, or building things the same way we built them before, but simply doing it in cloud. It doesn't give us those benefits, right? It doesn't give us the value, and so it doesn't fix our issues. The thing that we need to do is we need to leverage the strengths that the cloud provides. So the cloud gives us things. It's not just somebody else's data center that somebody else is managing the servers for you. Yes, it is that, and that's a useful thing, but it gives you some more powerful things. And it's this ability to provision infrastructure on demand and dynamically, right? And so these are things that I think we know. It's not that people don't understand that this is something that's available with cloud. It's that when we look as an organization, especially an existing organization, moving things into cloud, we don't often think about how are we going to use those things. We think, let's get our things into the cloud, and then hopefully we'll just see some benefits from having done that. So where application-driven infrastructure comes in, and this is just a way of thinking about how to kind of design and build things like platforms and our use of our infrastructure and cloud infrastructure in particular. So the idea here is to just drive our infrastructure provisioning from the application requirements. So rather than saying, let's build a static environment, let's build servers and environments and so on, and make them available to deploy applications and seeing those as kind of separate things, let's make it a more holistic thing where the infrastructure actually comes from what the applications need. And so there's two parts to this. The first part is defining what the applications require from the infrastructure, and figuring out what that is. The second is in actually provisioning infrastructure in order to meet the requirements that you've defined. So I'm going to talk about both of these in this talk, but most of what I'm going to talk about is that lower part, the provisioning of infrastructure. And the defining of what applications require is kind of an interesting problem. I think it's one of the more interesting problems that we have to think about. And so I'll kind of lay out a little bit about that. And then that's going to be kind of an open thing for us to explore as an industry and as people working in whatever kind of organizations we work in. This is stuff that we need to do. So again, the useful thing about the cloud is that we can provision our infrastructure dynamically. This is the thing that we need to take advantage of. So obviously we're going to do infrastructure as code, right? Because that's kind of what I like to talk about, right? And this is where I'll just bring into the book. The book, the second edition of Infrastructure as Code, talks a lot. It gives a lot of detail on some of the things that I'll be talking about in terms of how to design and build infrastructure in ways that will make it easier to do these kinds of things of making it driven by infrastructure requirements. So going back to this kind of classic divide of our applications and our infrastructure, the key idea here is let's introduce or let's have a look at those things in between that are what the applications actually use. So I've called them here technology capabilities, and you can call them platforms. And obviously Chris and Cristobal are going to be talking more about platforms in general. I'm kind of using this as a kind of a more generic phrase, I guess. Or actually, I would say maybe less generic in that it's specifically about what do our applications consume, and what is their view of the world. So application runtimes in particular are things like our application servers, databases, message buses. They're the things that the applications know about and need and use directly. Whereas you have the underlying infrastructure resources are that's kind of bundled together and it's consumed as runtimes. And then delivery services are just things like, what do you need in order to make changes and test changes and deliver them? So source code control systems, pipeline services to manage pipelines and those kinds of things. And then ops services are runtime monitoring and those kind of things that we need to manage our applications. So this is just kind of a useful model of kind of thinking about some of the kinds of capabilities that we need in our system. So the reason, one of the big things to think about, one of the things I think that organizations often miss, particularly when they're moving to the cloud, is they think we're going to have cloud and it's going to provide this stuff for us. It's just going to be out of the box, and so we can, we're now, we've signed a contract, we're getting accounts with the cloud vendor, and so we can just let our developers loose on it, and they have what they need, and so we don't need to worry so much about, whereas before we had to do kind of infrastructure management. The reality is that, like, this part is stuff that you're going to have to manage yourself. The cloud vendors, they tend to provide you with a box of parts. It's kind of a loose box of parts that you need to figure out how to assemble and connect together. And you do need to take the time to think about how you want to use them and how to make them more useful to developers. Because what will tend to happen if you do that kind of migration of just saying, here's the cloud, cut loose, go and do what you need to do, is that application teams spend a lot of time trying to figure out how to use things and put them together and assemble them, and also how to do that well and how to avoid the kind of pitfalls, how to make sure that we're doing things securely and so on. And so there really is more work than I think people tend to assume in building out this layer of capabilities and how you use cloud infrastructure. So to give kind of a simple example here, let's say we're a financial institution, and we have one of our applications that we're running is for loan applications. So customers can go to our website or use a mobile application, and they can apply for a loan through this application. So an application team is building and running this application. And now they need a number of capabilities in order to deploy and run their application. So in our case, one of the things that they need is a JBoss application server cluster. It could also be, Docker. Maybe their packaging is Docker, and they're running on a Kubernetes cluster. They're probably also going to need some other services in addition to this. They might need databases. They might need message buses and so on. But if you just look at the example of, here's one capability that we need to provide for applications, for this application to run. And you say, well, we're going to assemble that for some infrastructure resources. So a virtual machine cluster, maybe an auto scaling group, some network routes, maybe things like load balancers, security groups or firewall rules, the kind of different things that are needed in order for network traffic to work in the context of this application server cluster. And maybe some block storage, maybe there's some storage that's needed to run the application servers. And so, these are all the things that are needed for that capability to provide that cluster. But the details underneath are things that the application team may not need or want to have to think too much about. And so how do we build this stuff? Well, if we kind of isolate this out, obviously we want to do it as code, right? We want to define some code that we can use to build the pieces, to assemble these resources and configure them in a way that is useful for the application team in the format the application team needs. So then we get into the problems of what tends to happen with organizations that are with teams that are building infrastructure and using infrastructure at very much scale, and not necessarily just scale in terms of the amount of transactions and say that the end users who are using the system, but also the number of people within the organization, maybe developers who are using things, team members who are working with things, is that it becomes very large and bulky and difficult to work with. And so I've seen cases where teams have a Terraform project, say, that takes more than an hour to run Terraform apply because it's managing multiple databases across multiple teams, Kubernetes clusters, web servers, and so on. And so we need to have a better way than just having an infrastructure project. It's one big infrastructure project. We need to have a sensible way to structure and manage our infrastructure code. So obviously we want to split the project out, right? This is not a surprising conclusion to come from. We're going to take all that infrastructure that we need and break it into composable pieces. And this becomes particularly useful then when you go to that. So my example of the organization, which had an hour-long Terraform project to apply, because they had that project was serving multiple applications and multiple teams. And so by breaking things into composable pieces, we can think more about, okay, what are the pieces that any individual application needs, and what are the pieces that we need for this particular application instance? And so how can we manage and provision that more appropriately? So then the question is, so how do we make our infrastructure composable? And a kind of popular approach is to think about modules. And when I talk about modules, so the concepts that I'm talking about cross over different tools. So typically, if you're looking at a tool like a Terraform or CloudFormation or something like Pulumi or Ansible, or one of these tools which manages your cloud infrastructure for you, these tend to have ways to kind of build your infrastructure from components, from modules. And Terraform modules is kind of the classic example, and the one I often refer to when I'm talking about this, but it applies to all of them. And so the issue with using modules for this kind of thing is that it doesn't really help you with this thing of the very large block of infrastructure in your instance. So if you take that project that takes an hour to run Terraform apply, you organize that into modules, that helps you in terms of code organization and maybe even some amount of code use and code sharing, because you now have these different code components. But when you actually run the tool to create some infrastructure or to make changes to your infrastructure, it's still working on that whole big monolithic kind of blob of stuff. And so you still have all of those challenges of the time that it can take to run commands, the fragility, what happens when a command fails and it might leave things into a bad state. It becomes very difficult to work with. And again, these kind of module level reuse doesn't help with that particular problem. So what I tend to recommend is to think about using stacks as the way to compose your infrastructure. If you've got any complexity to your infrastructure, really, I think moving to stacks tends to pay off fairly quickly. And by stack, what I mean is an independently defined and manageable unit of infrastructure. So it's basically, when you have your infrastructure code and you run the tool to take that code and apply it to whatever is in your actual infrastructure, what's the kind of unit that it might change? What's the kind of scope of that bit of code base? And so a Terraform project with a state file is one example of that. Obviously, CloudFormation and Pulumi and a few other tools directly use that term stack. And so it's pretty easy to kind of map to that. Then the next problem you get is the coupling between these stacks. So again, what happens is you take that very large project, you break it into maybe separate Terraform projects. But if you still have tight dependencies between them, it becomes very difficult to make a change to one of those stacks without potentially breaking another part of the stack, or needing to go and change that other stack in order to make your change. And so things can still be very brittle, still be very fragile, still have all of those kind of original problems. There's people use the phrase sometimes distributed monolith, to where you take a system which, maybe it's a monolithic single deployable, maybe you break it into small pieces, but it's actually still very tangled and still not something that you can work with each piece independently. So two aspects of dealing with this that I'm going to talk about. One is the design. So how do we design our infrastructure code and the things that it represents, the actual infrastructure instances that it builds, to be loosely coupled? And this is one of these things. So a lot of these things that I'm talking about are things that in some ways they seem obvious and logical, but when you look at what is typically happening on projects, and even with the way that many vendors and say tutorials and so on that you read out there about infrastructure code, the way that they kind of recommend doesn't necessarily align with some of the lessons that we've learned in the software industry, say over the past 20, 30 years in terms of how to design software well. So just as an example, I'll give a couple of kind of principles which tend to come from software design and software architecture and point out that we can apply them to infrastructure, right? So the single responsibility principle, the idea that when you make a stack, it should be cohesive. It should deal with one thing, and manage the infrastructure for one thing. I think some important wrinkles to this is that you do need to think about what is the responsibility, what's the right level, because it might not be obvious. You could take this to an extreme and have many, many very small things, each handling only one small piece of infrastructure, saying, well, that's the single responsibility principle. But actually, the responsibility, it's kind of like domain modeling, where you need to think about, what kind of goes together, what's going to be managed together, what's going to change together. And so you need to kind of, use some judgment, which is often the case with using software design principles. And then similarly for separation of concerns, it's kind of maybe a flip side of that, of saying that we need to kind of make sure that things aren't too, that each thing is handling its own responsibility. I'll give an example here. So one way that people tend to think about with infrastructure is, well, networking. Networking is a separate concern, right? So traditionally, in terms of infrastructure and infrastructure architecture, we've separated out networking. But in practice, it might not be a separate concern. So in that example of a JBoss application server cluster, well, networking is part of the concern of that cluster, because you have to think about, how does traffic get into that cluster? How do you load balance traffic between servers in the cluster? How do you make sure that the right ports are open and other ports are not open, and those kinds of things. And so actually, whereas your first instinct as to what concerns might belong together, is worth reconsidering and thinking about, what's really important for the thing that this piece of infrastructure is actually providing, what capability. And this again is to bring it back to that application-driven infrastructure, thinking about what the application needs. And what makes sense from that context, I think, can help with making these kind of decisions. And then another principle from software design that is, I think, very relevant to infrastructure is this law of Demeter, which is basically the idea that the code in one piece of the system, so one stack in the case that we're talking about, shouldn't know the details of what's inside another stack. And this is something that I think is very commonly violated in infrastructure code, and in examples that even vendors recommend, where they say that, for example, maybe you have one stack that provisions some common networking structures that multiple applications need to use, and then you have separate stacks for each of those applications. And maybe those applications know the details of how that networking structure is provisioned, what it's called, how it's tagged, and so on, and is using that as a way to find that and kind of integrate the things together. And so this is one of those things where I think things that we're doing now might not, we're kind of relearning the hard way lessons that maybe we should have learned from software architecture. And so I'll give a little bit more, some examples of how to do that better. But another thing I'll just throw in as kind of a bonus rule here is aligning design with team structures. This is basically the inverse Conway maneuver. And most of what I'm talking about will be familiar to you if you're familiar with microservices and some of the thinking around those kinds of architectures. One thing that always comes up there is Conway's law, that your system structure is going to tend to reflect your organizational structure. And this certainly comes true with infrastructure. So it's important to think about what is the right design that we need for our infrastructure and our infrastructure code, and how should our organizational structure be aligned with that, and which may require some changes on either or both sides of those kind of designs in order to get right. And so now I'm going to talk a little bit about how do you integrate these stacks technically. How do you actually implement, if you have dependencies between some infrastructure stacks. So for example, again, you've got this shared networking. This one stack provides some common networking, which multiple application stacks might need to actually use. So they define subnets perhaps, and then application servers get deployed within those subnets, the application servers being created in a separate stack. So one rule that I would very strongly recommend is to make your stack dependencies configurable. And so this is like the idea, and this is probably one of the lowest hanging fruit, because it's very common. Again, and when you see examples of how to write Terraform code, for example, they'll say, well, how do I find the subnet that my application server gets deployed into? And you'll see a code using what in Terraform is a data construct, which says, go and look up and find it Here's what you can expect it to be named, or maybe there's some tagging or other kind of thing, or maybe you can look into the data file of another Terraform project that creates it and go and find that from that data file. And going back 20 years plus in software architecture and object-oriented design, there was this whole idea of inversion of control and dependency injection, and saying, rather than my code finding the dependencies in somebody else's code that it needs, let me just say, I need this thing, I need a subnet. And then to put the kind of responsibility for specifying, okay, what is the subnet that was created by that other stack, kind of outside of that, which then creates, first of all, it creates loose coupling, right? So you can do things like testing your application server stack without necessarily needing to use the other stack. You can use a much simpler bit of kind of a test fixture to say, I just need a subnet, and then I can provision my application server stack, and then I can test it on its own and keep it more loosely coupled. And maybe I can reuse it in different contexts with different shared networking stacks that serve different purposes. For instance, a networking stack for things that are public facing versus those that are internally facing. And then another important thing to do is to define the interface contracts clearly, understanding what they are. And again, this is something that I think we often fail with infrastructure code. And the examples for that, where you get, again, projects depending on things that other projects have created without that first project, that provider project necessarily being aware somebody's using this thing. And so it becomes a situation where, for example, that network, that shared networking stack, well, we're really afraid to make changes to that because we don't know what we're going to break, because we don't know what people are depending on. So where you're kind of designing these kind of things, you want to be very clear. So with my shared networking stack, I'm going to say, I'm going to expose some subnets, and here's how I will expose them. And you can depend on those. I'm going to treat those as a contract, like an API. Anything outside of that, you shouldn't rely on. You shouldn't assume that you understand what's inside and how I've provisioned things and what I've named them, for instance. So the idea of using test-driven development, these kind of agile engineering practices that we're used to from the software development world, we still find very challenging, and even I personally find very challenging to do with infrastructure because the way, the tooling and the kind of ecosystems are not very mature and are not very geared up to do this very well. And also, I think some of the design problems that I discussed, when people fall afoul of those and don't have loose coupling between their pieces, or have pieces that are too large, it makes it difficult, right? So this is a very challenging thing to do. And I think people are often don't appreciate the full reasoning for using these practices with infrastructure. They think, why do I need to have an automated test for infrastructure? I'm going to build my infrastructure and then it's there. I can test it, and if it's okay, it's okay, and I don't need to worry about it anymore, right? And just as with software, I think we need to kind of learn that hard lesson that actually we change our infrastructure much more often than we think we do. We do patches, we do fixes, we do configuration changes. If you sit back and look at it, you're making many more changes than you think you might think that you do. And so the point of infrastructure testing isn't just to test the correctness, it's to give the confidence to make the changes, and also to help with those kind of design issues. So if we use our pipelines to deliver changes to infrastructure, and if we design those pipelines right so that we're thinking about each of those stacks, for example, as independent pieces, we can ensure loose coupling by using those, because we're going to say we have a stage where we deploy our application server stack on its own independently. And so we use a test fixture for things like, okay, it needs a subnet, that's fine. It doesn't need all of the front end stuff that we need in order to accept connections for the public internet that's provided by our shared networking stack. So we don't provision that shared networking stack. And by having the pipeline which deploys and tests the application server stack on its own, we discover if we've made some kind of assumptions about what's provided in terms of infrastructure other than what's in the contract. And so these pipelines really help us with keeping that kind of clean design. It's often been said about test-driven development that it's not really, the purpose of test-driven development isn't so much to create tests as it is to drive design, to drive good design. And that's just as true with infrastructure as it is with software. And we can also use pipelines to support governance and operational quality. And I'm looking ahead to what Katerina has to say about about agile and security, but using pipelines and automation is a really powerful tool in this regard. When you have things like compliance as code and so on, this means things that we can test in our pipeline, not just about our applications, but also about our infrastructure, to make sure that our infrastructure is compliant. And not just to make sure that it's compliant, but also to provide those audit trails that regulators might need when an auditor comes in, to be able to see what's changed in our system, when was it changed, how was it changed, to be able to have not just a run book that says this is how we make changes to our system, but the actual code that makes those changes, the actual code of the tests that run to confirm that, yes, it is compliant, and the results of those tests for every change that's been made to the infrastructure. That's very powerful and very useful. So I'm bringing it back again to this idea of the application-driven thing. So I spent most of the time of this talk talking about how we use this infrastructure as code to if we do the things that I've talked about, it makes it much easier than to kind of do the other part, to say that, we now have pieces of infrastructure which are composable and that we can call on demand based on what our applications need. So what does that side look like? Basically, we need to be able to define my application, what does it need from the infrastructure? So going back to this picture of where we have the applications and the infrastructure and these technology capabilities in between, and that example where we have our application, loan application service that needs a JBoss server. So we could basically have a specification which says, here's what my application needs. It needs a JBoss cluster, right? The way I've written my application, I'm building it as a war, and it assumes probably a certain version of JBoss, probably some certain kind of conditions around things that we can kind of put into a specification. We'll probably have other requirements as well. So I need a database, maybe I need a message bus, maybe I need a few other things. So we could put those in the specifications. The important thing is the application team is able to do this, and they're doing it from their point of view. How do I see this stuff? So I'm not looking at routing tables and IAM policies and very very low levels of details. I'm interested as an application developer or an owner of an application. I'm interested in, I need JBoss, and I need a few things about that to specify. Maybe I want to say I'm a public facing application, so you need to kind of set up the right things to give access for people in the public to come to my application, and you need to secure it. You can do all the things that you would need to do to secure it. You can do that, knowing what I've told you about the application. And then your automation kind of orchestrates that infrastructure provisioning. So it says, okay, given what you've said, you need a JBoss application server cluster. I can now run Terraform or whatever it is. I can grab these different stacks. So it might do things like, for that JBoss cluster, it might say, okay, I know you need a JBoss cluster, and here's the stack code that I'll use to do that, and I can provision an instance for you. Or it might say, actually, given the contracts that we have here, you can use a shared JBoss cluster that already exists, and I can understand, again, because I understand the requirements from the specification, I'll allocate that to deploy into that and manage that for you. But the details of that can kind of be handled. So then the kind of final question on this is, how do we manage this? How do we make this happen? And there are a couple of things. This is the unsatisfying part, because there's not really much there for us now to do this nicely. What most organizations I run into do is they do it themselves. They roll their own. So there are various kind of tools that teams make, often using YAML to say, for an application deployment descriptor or what have you, and then using that to kind of create infrastructure. There are some products, so to a certain extent, some of the products that are out there help usually with elements of this. So if you look at things like Kubernetes and Helm charts and these sorts of things, these provide part of the equation, but they don't tend to have everything, right? They don't tend to have things like, okay, well, how do I provision a database? How do I, how do I manage traffic from the outside? How do I, how should I be monitored and so on? Especially in organizations which have systems which are not all being written from scratch to kind of fit into that kind of Kubernetes ecosystem kind of world. And then there are kind of standards. So there's the open application model, which we've referenced in the Tech Radar, and I think we've refreshed that in the most recent Tech Radar, Thoughtworks Tech Radar. which is it's quite interesting. It's not anywhere near a final standard, but to me, it's a very interesting example of an attempt to solve this problem and to create a standard for solving this problem. And there are some kind of reference code out there of people who are building frameworks to kind of manage that. But I think for the time being, I think the useful thing is to think about how you might use this in your own organization. And particularly, again, going back to that theme of application driven, we really want to think about not just some team providing infrastructure in a kind of static way, but having infrastructure that can be provisioned according to what the applications need. So just to kind of close off with a summary of what we need in order to make this shiny world happen. We need these kind of provisioning solutions. The thing I just mentioned, we need some way to be able to specify this is what my application need, and then have some kind of tooling that will then provision this stuff for us. We need to get better design practices for our infrastructure code than I think what is the norm in the industry now. So we need to really think about how to do more of that and do better at that. And this is something we're still learning. I don't think this isn't one of those things where it's very clear cut, how to do it. We're still feeling our way and learning lessons from this. But we need to do better. And then there's that kind of continuous delivery, test-driven development. Again, I think the state of the industry, the state of the art in terms of tooling and practices and patterns that people tend to follow and recommend to one another is still not there yet. And I think we still have more to learn, but those things will support doing this. So thanks for listening. I guess we'll have a look at the questions and see what people are wondering from all of that.